Hi, welcome to Comet Computer Private Limited, e-learning program of Azure Public Cloud Training. Myself, Ilan Cherian, Technical Director at Comet Computer Private Limited. And this is our seventh video of Azure Public Cloud Training. And in this video, we'll be discussing about the connectivity services. As in the previous video, we have discussed that the connectivity services provide connectivity between Azure resources, connectivity from on-premises network to Azure resources, and branch-to-branch connectivity in Azure. So for this connectivity, Azure uses many services, which includes Azure Virtual Network, Express Route, VPN Gateway, Virtual WAN, Azure DNS, and Azure Bastion, Virtual Network NAT Gateway, and Azure peering services. So out of all these services, initially we'll understand about the Azure Virtual Network. So Azure Virtual Network, in other words, it is also called as VNet. So VNet is the fundamental building block of your private network in Azure. VNet is scoped to a single region or location. However, multiple virtual network from different regions can be connected together using virtual network peering. So VNet is scoped to a particular subscription. So you can implement multiple virtual network within each Azure subscription and Azure region. As you build your network in Azure, it is important to keep in mind the following universal design principles. So while creating the VNet, we need to ensure there is no overlapping of address spaces between your on-premises network to Azure VNet or between the Azure VNets. So make sure your VNet address spaces, that is the CADR block, doesn't overlap with your organization's other network ranges. And your subnet should not cover the entire address space of the VNet. Plan ahead and reserve some addresses for future. It is also recommended to have fewer larger VNets than multiple small VNets. So this will prevent management overheads. And also you can secure your VNet by assigning network security groups to the subnets beneath them. And about the address spaces of the VNet. So when creating a VNet, you must specify a custom private IP address space using public and private addresses. Azure assigns resources in a virtual network a private IP address from the address space that you assign to the VNet. For example, if you deploy a VM in a VNet with address space 10.0.0.0/16, the VM will be assigned a private IP like 10.0.0.4. And understanding about the subnets, subnets enable you to segment the virtual network into one or more subnetworks, that is the smaller networks, and allocate a portion of the virtual network's address space to each other. So you can deploy Azure resources in a specific subnet just like in a traditional network. Subnets allow you to segment your VNet address spaces into segments so that are appropriate for the organization's internal network. So this also improves address allocation efficiency. So you can secure resources within subnet using network security groups. You can deploy VMs and several other type of Azure resources to a VNet, such as Azure App Service Environment and Azure Kubernetes and AKS, that is the Azure Kubernetes Services, and the Azure Virtual Machine scale sets. You can connect virtual network to each other, enabling resources in either virtual network to communicate with each other using virtual network peering. All resources in a VNet can communicate inbound to the inbound and outbound within the VNet, but communication between the VNet and the internet. So by default, VNet can communicate outbound to all the internet resources by default, but all the inbound traffics are disallowed by default. But traffic within the VNet inbound and outbound is allowed by default. You can connect your on-premises computers and networks to a virtual network using VPN gateway or express route. And now we will understand about the on-premises network and the Azure VNet so that it will be easy for you to correlate your on-premises setup with the Azure setup so that it will be easy for you to understand the Azure network and its setup easily. So as we have our on-premises network, we'll have our production servers and we'll have our end user computers, that is the end user production user network, which will be connected to the LAN interface of your firewall, on-premises firewall. And also we'll have a DMZ, that is a demilitarized zone or a perimeter network. So where we'll have all our hosting servers like a web server, FTP server, email server, or a terminal server. So for this kind of servers, we'll have a different subnet. So for hosting servers, we'll have a different subnet. For production servers, we'll have a different subnet. And your production user network and your production server network will be allowed to communicate each other by default through the required routing configurations or the firewall configurations. But all the traffic from internet to the LAN network are denied by default, and this allows you to protect your intranet resources directly exposed to the public internet. And also, since we have some hosting servers like web server or FTP server, email server, and terminal server, so these servers has to be accessed from the public internet. So that in firewall, we'll configure the respective rules to allow the port or the required traffic to the hosting servers. Say example, if we are hosting a web server with port 80, so in firewall, inbound traffic to this particular web server will be allowed through port 80. And if it is a FTP server, we'll allow the port 21, and if it is an email server, we'll allow port 25, and it will, if it is a terminal server, we'll allow port 3389. So these traffics are allowed from the public internet to the DMZ where the hosting servers are available. So with this diagram, you can understand it very clearly. All the traffic which comes inside your network or which goes outside the network, it is completely controlled by you. It is completely managed by you. So similar kind of isolated network, similar kind of a controlled network we should be able to have in our cloud also. So this Azure also has this kind of network. Since this on-premises network, we call it as a private network. And we can also call this a virtual network, which is nothing but a private network inside the cloud. So as like you choose what IP range you use in your on-premises network. Similarly, while creating a VNet, you can also define what the IP range you are going to use inside your VNet. And as like we have your hosting servers and production servers in different subnets. Similarly, in VNet also we can create multiple subnets so that we can keep our production, that is the hosting servers in one subnet and the production servers in another subnet. And also based on our requirement, we can allow the traffic from external network to the VNet. Usually the hosting servers should have internet access, that is all the traffic based on the port. If it is a web server, we need to allow port 80 to the web server. If it is a email server, we need to allow port 25 to the email server. Similarly, we can configure the firewall rules. Here in Azure, we have a firewall, that is a virtual firewall, which is called network security group. So by configuring the appropriate rules in the network security group, we can allow the respective traffic to the virtual machines. And by default, any virtual machine you create in Azure VNet will have the internet access, so that these virtual machines can be accessed from the public internet. So through public internet, anyone can access these virtual machines. But for a production requirement, my production network users should be able to access these production servers using the private IP, that is the internal IP. But by default, production network users will not be able to access the private subnet computers, that is the production subnet computers. If we want to allow this traffic, if we want to allow the production user to access the private subnet computers, so we need to configure a VPN. So after establishing VPN between our subnet of VNet and our on-premises, so that these production network users can access the private subnet computers using the private IP, so which is going to be a secured way of communication. So usually even in our on-premises setup also, we'll have data center in one location and the end user will be sitting in another location. So we'll have a VPN established between these two locations, and the end user will be accessing the required services as they are available in their local location. So similar like this, the cloud also provide us the functionality similar like our on-premises setup. So after establishing the VPN between the cloud VNet to the on-premises network, so that end user can access their resources through the VPN network. So I believe you got a good understanding about comparing the on-premises network to the Azure network. And now we'll also have to understand about the Azure VNet IP addresses. Uh, as we discussed earlier, while creating a VNet, we used to define the a CADR block for the entire VNet, and this entire VNet can be broken into smaller pieces, that is the subnets, so that we can break the big VNet into smaller logical networks, that is the subnets. So whenever you create a subnet, so in that subnet you need to define the IP range for that particular subnet. And when you connect any virtual machine in that particular subnet, the virtual machine will get a private IP address from the defined range. So every virtual machine you create inside the VNet, that is inside the subnet, will have one IP address created and allocated automatically. So this IP address which is allocated in the range of the subnet, so this is called as the internal IP address or private IP address or dynamic IP address. Since these IP addresses are allocated dynamically, so that's why it is called as a dynamic IP address. And based on your requirement, you can also reserve this IP address so that you can make this IP address static for your virtual machine. And also when you create a virtual machine, along with the virtual machine, cloud service will be created. So this cloud service is nothing but the service which provides internet access to the virtual machine. Something like you can understand like your home broadband connection. So through the broadband connection, your laptop or a desktop at your home can get the internet access. Similar like that. So the cloud virtual machines will get internet access through the cloud service. So this cloud service, one end will be attached to the public internet, the other end will be connected with the virtual machine. So since the cloud service has two interfaces, you can assume like it has a two interface. So one interface is connected with the virtual machine, the other interface is connected with the public cloud. So the interface which is connected to the public internet, which will have an IP address, which is called a virtual IP address. This virtual IP address is nothing but a public IP address, and even this public IP address is a dynamic public IP address. Whenever you power off and power on the virtual machine, so this IP address will change. So this VIP is nothing but a uh, dynamic public IP address. So using this public IP address, you can access the virtual machine, provided the network firewall should allow the respective traffic as like in your on premises. So anyone who is hitting the WAN interface, so the traffic based on the rules defined in the firewall, the traffic is allowed to the respective targeted host. So similar like that, so this cloud service will allow the traffic to the respective virtual machine. So based on the firewall configuration, which is nothing but the network security group. So as we discussed earlier, so network security group is something like a virtual firewall. So inside which where we can configure the rules. So as like we configure the inbound rules in the firewall, here in NSG also we can configure the inbound traffic. So whichever the port should be allowed on the port number, and then the traffic direction. So that can be defined in the network security group. So based on the rule defined in the network security group, so the respective traffic is allowed from the public internet, so that the public internet user can access to the respective services which is hosted in your virtual machines. So in this example, I have just shown this diagram to publish a web server. If it is a email server, we can allow port 25, 110 or 143. So based on the traffic used, and if it is a I would say if it is a FTP server, we can allow port 20 and 21, and if it is a terminal server, we can allow uh, port 33810, and even we can create separate network security groups for separate virtual machines, or we can create a network security group for services. So based on your environment, how efficiently you are going to manage these network security groups, it's absolutely up to you. And as I said earlier, this virtual IP address is a dynamic public IP address. So when you power off and power on the virtual machine, this IP address will change. So if that is the case, you will not be able to create a record in the public domains. So in that case, we need to have a static public IP address. So the static public IP address, you can also reserve this virtual IP address. We can also call it as a RVIP, reserved VIP. So this reserved VIP is nothing but a public IP which is reserved for you. It means it is a static public IP addresses. So that once you when you reserve this public IP address, so this IP will remain permanent unless until you delete the public IP. So that in that case, if you are hosting a web server or email server or a terminal server, in that case, it is always recommended to have a static public IP address. So where we can reserve this virtual IP. So, and also while reserving a public IP, Azure will warn you that the changing the status, that is changing from dynamic IP to static IP. It is not that you will get the same IP, or your virtual machine may get restarted. So keeping all these in mind, you first test all these things in your test environment. After that, you can work it out in the production environment. So I believe we got a good understanding about VNet, subnets, address spaces, and comparing on-premises VNet to the on-premises network to the Azure VNet. So you'll be able to compare your on-premises network setup with the Azure network, so that you can easily understand how the network is architectured in Azure Cloud. And thanks for watching this video, and in the next video we'll be discussing about the connectivity services part 2. Until then, bye bye.